In this video, we're going to learn about trig functions for any angle. Previously, you found trig functions for positive acute angles, for special right triangles, angles in special right triangles. From now on, we're going to find trig functions for any angle. So look at the diagram on the left. This angle is theta. So theta is an angle in standard position, one side on the x with the terminal side with a P on it, with point P. And the coordinate for point P is x and y. Therefore, this is my y, this is my x. Now you see why I wrote x squared plus y squared equals r squared. By Pythagorean Theorem, that is correct. If you want to simplify that, you can take a square root. You will find the value of y. Once you have that, you want to look at, this is the part that's really important. Now, the right triangle is here. This is the right triangle here. Therefore, even though you have angle theta, you want to use this angle. It's 180 minus angle theta. And from that point, you just use SOHCAHTOA and look at theta is opposite, which is y, over adjacent, over hypotenuse, h, right, which is r. Excuse me for that. And cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA, you got it. Then the remainder three are just reciprocals of what's on top. And cotan is x over y. That's it. Very easy and straightforward. Okay, let's look at some practice problems. Point P is at 9 and negative 12. So immediately draw a diagram. You have 9 being positive, negative 12 is probably around here. So this is P, which is 9, negative 12. And you want to have a terminal side. And then you want to have your x-axis this way, y-axis that way. Oops, sorry about that. Now you're looking at this angle here. And P is here, so if I draw a straight line to x, my r is here, my 9 is here, my negative 12, or absolute value of negative 12 is this distance. Should use a different color. Green is the absolute value of negative 12. So now I can use Pythagorean Theorem, find r, which is 9 squared plus negative 12 squared equals r squared, and r is 15. So now I have x equals 9, y equals negative 12, r equals 15. Then sine is opposite over hypotenuse. That gives you negative 4 over 5. Cosine is adjacent over the radius, which is hypotenuse. So I have 3 over 5. And tangent is just y over x. I'm just doing a reciprocal because I'm being lazy. If I'm more diligent, I can go back to remember the definition of the last three as well. Okay, fairly straightforward. So again, you take the coordinates, graph it out in the coordinate plane, find the radius, and now you have, by using Pythagorean Theorem, now you have all three sides. Then you can calculate the trigonometry function values. So I will not do this one, second one with you, but I will help you graph out what you need. So that's 6, that's about negative 2, and then you have to draw a line there. So point here is point A, it's -6 and -2. Okay, and here are the answers. This one has a little bit of you need to know how to simplify a fraction so that there's no radicals in the denominator. You can pause the video, finish your calculation, then come back and verify your answers. I'm just putting it here so that you don't need to flip-flop back and forth between the key and the notes. Okay? So that's trig functions for any angle. Now, let's look at, let's study the sign of the of trig functions. And before we do that, I want you to do this. Remember this, all students take calculus, which is a very famous line in pre-calc. Every teacher uses it. I love it. All students take calculus. Also remember, I do not know why, but let me use black ink. We call this first quadrant, second quadrant, third quadrant, and fourth quadrant. I don't know why we go counterclockwise, and I don't know why we always use Roman numericals, but it makes us look smarter, so why not? So when we have an angle, we put it in a standard position with one side on the x-axis with a terminal side anywhere in any of the four quadrants. The trigonometry functions can be positive or negative. And how do we know which one is positive, which one is negative? I will go into that a little bit later, but for now, I want you to write down in quadrant 1, all 6 are positive. Quadrant 2 is only sine and cosecant, because cosecant is reciprocal of sine. And in third quadrant, only tangent, therefore cotan, are positive. And in fourth quadrant is cosine and secant. So that's why we use all students take calculus, because the first letter of each word in that sentence represents a trig function that's positive in that quadrant. So in other words, in first quadrant, all 6 are positive. In second quadrant, only sine, that's what the S is for. If sine is positive, cosecant has to be positive. Third quadrant, tangent, therefore cotangent, cotan has to be positive. Fourth quadrant is only cosine, which means secant as well. Okay? So now let's look at some of these questions here. If cosine theta is greater than 0, which quadrants could the terminal side of theta lie? What do you think? So first of all, if it's positive greater than 0, we have quadrant 1, right? But because it's cosine, we go immediately to C, so we have 4 as well. Second one is tan theta is less than 0, so it's negative. Which quadrants could the terminal side of theta lie? So first, tangent is positive in first and third. Therefore, if it's less than positive, it has to be 2 and fourth quadrant. Excuse me. For secant less than 0, which quadrants could the terminal side be? I like to ignore secant. So if secant is less than 0, cosine has to be less than 0. Cosine is positive in first and fourth. Therefore, 2 and 3 is our final answer. Last one is if sine is less than 0 and cotan theta is greater than 0, which quadrants could the terminal side of theta lie? So for sine to be less than 0, it can only be third and fourth. That's sine theta, right? And then for cotangent to be greater than 0, it has to be 1 and 3. Guess what? There's only one place, one quadrant, which is the third quadrant, where both conditions can be satisfied, where sine is positive and sine is negative and cotangent is positive. Because in 1 and 4, in 4, cotangent is positive. I'm sorry, in 4, cotangent is negative, so it doesn't work. In 1, sine is greater than 0, so it doesn't satisfy that. So you have to have both in there, and that's your final answer is 3, quadrant 3. That's your final answer. So signs for trig functions, you just have to remember all students take calculus. Now, using trig values to find other values. This is so easy once you get the hang of it, but at the first look at it, it's a little intimidating because it's slightly abstract. However, I want you to follow these steps, so write it down on the side or in your notebook. For this type of problem, they usually give you one trig function, then give you some other hints about the signs, then ask you to find the other 5. So the first thing you need to do is to determine the quadrant. Which quadrant is theta in? Determine the quadrant. First, second, third, or fourth. Then you have to know or find out your signs. Do you expect the 6 trig functions to be positive, positive, or positive, negative, or negative, negative, or negative, positive? Which one do you expect to see for each of the 6 trig functions? And then you just do SOHCAHTOA. SOHCAHTOA. So let's see, how do we apply that? I have to determine which quadrant it is in. So, okay, let's do all students take calculus. So for sine, I have obviously first quadrant to be positive, second quadrant to be positive. For cotangent to be negative, it has to be second or fourth. Guess what? Which one overlaps? Obviously, just second quadrant, right? So now we're in quadrant 2. All right. In quadrant 2, if you notice that I have my x value being negative and y being positive. So what I often do, ladies and gentlemen, is I simply do negative, positive, just to put a note there to remind myself. So now I can go ahead, and if I know I have sine being 8 over 17, sine is opposite, so if this is my theta, this is 18, this would be 17, right? And if I call this, like here, that I'm making it thicker, if I call this a, I should be able to use Pythagorean Theorem. A squared plus 8 squared equals 17 squared. So if you solve that, that will give you 15, I think. Check my math. Now that you have all 3 sides, nothing is stopping you, right? You've got the triangle there, then you can calculate the other 5. So leave a little bit of space in front of your answers. So if it's cosine, I would have ca, which is adjacent, over 17, and 10 is 8 over 15, opposite over adjacent. Then cosecant obviously is 17 over 8, it's reciprocal. Secant is reciprocal of sine, 17 over 15. Cotangent is reciprocal of 10. Now, we are not done yet. So the final step, I do it, is to check your signs again. Now, we already said that this angle theta is in quadrant 2. So in quadrant 2, we only have sine being positive, right? So if sine is positive, then cosecant is positive. Everything else should be negative. That's it. So let's look at the next problem. We first has to determine which quadrant it is, right? So I'll use red this time. So secant is related to cosine. Cosine has to be greater than 0, which means it can be in first quadrant. It may be in fourth quadrant. Now let's look at cotan. Cotan equals -4, which is negative. Cotan is only negative in second and fourth. Therefore, the common shared quadrant is 4. So we're looking at the terminal angle landing in the fourth quadrant. Any points on the terminal side would have a positive x and a negative y. So let's go from there. Now if I draw it, also when I draw it, be careful, cotan is -4/1, right? I actually like to deal with tens, so I'm sorry, I wrote it wrong. So let me erase that. So it should be 10 is the reciprocal. It's -1/4. Now I can graph it much easier. If I have theta here, sorry about that. Actually, we can pretend that it's in first quadrant. It's always easier to calculate it. Theta is opposite over TOA, over adjacent, which is 4. Okay, now I can do my C equals square root of 17 actually. C equals square root of 17. How did I get that? 4 squared plus 1 squared should be c squared. So 16 plus 1 equals c squared. Square root of 17 is c. Now I can do my trig functions. This is 1/√17. I actually wrote this, so I'm going to simplify that. I sort of jumped ahead, right? But cosine is simply 4/√17. And if I simplify that, if you don't remember how to simplify it again, come and see us. And 10 is 1/4. I'll check signs later. And cosecant is -17/1, which is just -17. Whoops, I put the negative there already. And secant is √17/4. So now let's look at signs. This is in the fourth quadrant. Therefore, sine must be negative, right? Fourth quadrant is only cosine. Cosine is positive, so this is positive. If tangent has to be negative, cosecant is related to sine. So if sine is negative, this has to be negative. Secant is the same as cosine. Got it? So number 9 is pretty much the same. So you can pause the video. Oops. You can pause the video and I will write out the answer key for you. So here's the answer for number 9. If you want to graph it, you can graph it. √5 is cosecant. Cosecant is 1/sine. So which means opposite is 2. Theta is here. And root 5 is there, and that's my 90 degrees there. Okay, that's it for this page, and I will see you later. Bye, guys.